In this video, we are going to be discussing question number 6.19. In case you have the older textbook, it's 7.19. Yes, I do have the older textbook as well. So in this question is related to the ionization of weak acids. Definitely check out the explanation of ionization of weak acids. I think it's 2 videos ago. So definitely check that out for more information on that. So in this question, the pH of the 0.1 molar monobasic acid is 4.50. Calculate the concentration of these different species at equilibrium. Also determine the value of Ka and pKa of the monobasic acid. So now first thing is that the word monobasic acid means that it can give us only one H plus ion. Okay, so monobasic acid is able to give us one H plus ion. So essentially the monobasic acid can be written as HA, which is in equilibrium to give us H plus and A minus. Okay, so it's very important because um, this gives us the information that the number of hydrogen ions is equal to the number of the additional ions that are released. Okay, now let's write down what's given to us. They've only given us the pH, which is equal to 4.50, and they've also given us the initial concentration is 0.1 molar. Okay, so that's given to us. We need to calculate the concentration of H plus, concentration of A minus, and the concentration of HF, HA at equilibrium. We also have to calculate the value of pKa and Ka. Okay, so the first thing that jumps to me is the fact that they've given us the value of pH, right? So from pH, we know pH equals to minus log concentration of H plus, right? So 4.50 is equal to minus log concentration of H plus. And then we can transfer this negative sign to this side. Okay, so that will mean that it goes from here to here. Okay, so when we take anti-log, essentially you have H concentration of H plus is equal to 10 to the power. I apologize for that. So it is 10 to the power minus 4.50. Okay, so this is equal to 3.16 into 10 to the power minus 5. So this is the concentration of H plus. Another thing is that concentration of A minus is equal to that of H plus, because look at the equation, you have equal number of H plus and A minus ions getting released. So this will be equal to 3.16 into 10 to the power minus 5. So we have been able to calculate the concentration of H plus and A minus. The next thing we have to do is calculate the concentration of HA, right? So for us to do that, what we'll do is concentration of HA at equilibrium will be equal to this value. So HA is from 0.1 molar is the initial concentration, right? So it's breaking down to give these two ions. So essentially what we can say is 0.1, oh, sorry. So it's going to be 0.1 minus 3.6 into 10 to the power minus 5. The reason being, this amount of HA was the one which broke to give us H plus and A minus ions, right? So all we have to do is simplify this. So we can just say 0.1 minus 0.0000. So we're moving it 5 times, 3, 6. So this is equal to 0.09964, which is approximately equal to 0.1. Okay, so we're just simplifying it to give us this final value. So we have been able to calculate the concentration of HA as well. The next thing we're going to do is calculate the value of Ka as well as pKa. Right. So first of all, Ka, the equation for Ka will be equal to concentration of H plus into concentration of A minus whole divided by concentration of HF or HA. I keep doing HF. I know it's because the previous video had hydrogen fluoride, and I've been thinking about that since then. Okay, so this is 3.16 into 10 to the power minus 5 into 3.16 into 10 to the power minus 5 whole divided by 0.1. Okay, so when we move the 0.1 from the denominator to the numerator, we can just say into 10, because it's basically 0.1 as in it's 10 to the power minus 1, and when we move it to the numerator, it becomes 10 to the power 1. So that's why we're just doing it this way. Okay, so it's 3.16 square into 10 to the power minus 10 into 10. Now this can change this to the power minus 9. And then 3.16 square gives us 9.88 into 10 to the power minus 9. Okay, so we've been able to calculate the value of Ka. Now the last step is for us to figure out the value of pKa. So pKa is equal to negative log Ka. So it's just going to be minus log 9.88 into 10 to the power minus 9. So we're going to simplify it as we have done for the past couple of questions. So log 9.88 plus log 10 to the power minus 9. So this one simplified log 9.88 is 0.99. So negative sign taken out and is outside the bracket. 0.99 minus 9, because this has a negative sign. So this when simplified gives us minus 8.01, right? So minus into minus is plus, the value of pKa is 8.01. So essentially what we did was we use the value of pH, which was given to us in the beginning of this question, and we were able to calculate the concentration of hydrogen, H plus ions. From there, we were able to figure out the concentration of A minus ions as well, because the number of H plus and A minus are equal to each other. Then we used this value to figure out the concentration of HA, and we assumed basically approximated it to be 0.1. And then we use the equation for Ka to calculate the value of Ka, and then use the value of Ka to calculate the value of pKa. I hope all of that made sense. In the next video, we will be discussing question 6.20.